Throughout the world, wired glass is recognised as satisfying fire legislation requirements, and in the UK conforms with a fire safety certificate requirement for the retardation of fire for half an hour. It's this property that architects know and rely on when specifying this product. Pilkington Glass Limited manufactures both obscured and clear wired glass. This video looks in detail at the manufacture of clear or polished wired glass. Today, the wired for polishing story has developed into three main products. There's diamond mesh, which satisfies customer requirements in the American market, Georgian mesh, which satisfies the UK and the rest of the world, and a new product which will come on stream in 1989. This new product represents a tremendous breakthrough in the wired for polishing story, as it will now satisfy British standards for safety legislation as well as the recognised fire retardant properties. The manufacture of polished wired glass begins at the Pilkington Watson Street Works in St Helens, 90 miles from Doncaster. Watson Street Works, like Doncaster, is part of the basic glass division of Pilkington Glass Limited. Here there are two manufacturing units, RP3, which produces rolled patterned glasses, and RP1, which produces wired glasses. In the early part of 1988, RP1 underwent a major reconstruction program which cost £7 million, and it now represents the most modern rolled wired production unit in the world. The unit produces 2,000 tons of wired glass each week, 70% of which is 7.8mm wired glass for polishing, and 30% of 6mm wired cast. When producing wired for polishing, the speed of the continuous ribbon is 300 meters per hour, and the final plate size sent to Doncaster is 3.3 meters by 1.98 meters. Watson Street Works maintains a very close technical liaison with the wire manufacturers, Tinsley Wire of Sheffield. This is a very important link in the polished wired operation, since the customer sees wire straightness as a main quality criterion. On receipt at Watson Street, the wire rows are subjected to a phosphating process to ensure that the final appearance of the wire in the glass is clean and acceptable. A lot of work has also been carried out recently on improving the method of feeding the wire into the glass. This has involved upgrading wire feeding equipment to make sure the wire is fed straight and uniformly into the glass bolster system between the first and second pass rollers in the manufacturing operation. After forming, the glass is cooled in a leer under strictly controlled conditions so that glass stresses and shape after annealing conform with strict specifications for the Doncaster grinding and polishing operation. Between Doncaster Works and Watson Street Works management, a strict glass specification has been drawn up, involving physical properties on the glass and quality specification for visual faults. Apart from stress and shape characteristics, the specification also looks closely at the flatness of the ribbon, roller wave, edge lift, and sets standards for wire straightness and other wire and visual faults. The overall specification is tight, but needs to be, to ensure that the plates can be satisfactorily ground and polished with minimum breakage and glass loss. Furthermore, the operation has to satisfy customer requirements on quality, since the finished product is considerably more expensive than other flat and rolled annealed products. At the end of the annealing leer, a strict glass examination operation is carried out by supervision and quality control technicians. 3 plates from each roll of wire are examined in detail by line supervision in a leer end examination booth. The glass is graded for full-size suitability for the export market, the home market, or cut-size quality. Quality control technicians support this examination by supplying relevant information on the physical properties and visual faults in the glass on a regular basis. This reporting system enables tank supervision and line management to make changes where needed, to ensure that the product quality stays in the specification required for the Doncaster grinding and polishing operations. The equipment in use at the Lear end has been developed over a number of years to ensure the plates are cut exactly square with good cut-edge quality, as these aspects could upset the Doncaster operation. Separation of the ribbon into individual plates is not straightforward, as the methods of breaking out cuts are different from those employed for ordinary annealed glass ribbons. The equipment has also to break out the wire as well as the glass score, and this is achieved using sophisticated tension snapping equipment. After breaking out the plates, the glass is examined before the plates are made into packs. These are made up by using horizontal stacking equipment, and packs containing 19 plates are assembled by this means. After pack making, the glass is transferred into the warehouse stocking areas, where it must stand for at least 12 hours before dispatch to Doncaster. This is important, as the glass is still not finally cooled to ambient temperature after the glass-making process has been completed. And if the glass were to be dispatched prior to this 12-hour period, thermal breakages could occur in the packs during transit. The edges of the packs are painted prior to dispatch to prevent water penetrating into the mild steel wire mesh to prevent rusting. Doncaster Works covers an area of 40 acres, employs just over 300 people, and its operations are mainly concerned with the processing of wired glass from St Helens. The grinding and polishing plant works on a continuous basis, 24 hours a day, 7 days a week. Other products, which are difficult to make by float glass operations, are produced from time to time when customers require a bright, polished finish from a rough cast plate of glass. The processing plant is housed in the No. 9 Grinding and Polishing Building, which started its operations in 1961. It cost £4.5 million then, and is now the only grinding and polishing unit in the Western Hemisphere. The competition comes from Japan, where there are 3 polishing plants, so the total world demand for polished wired glass is satisfied by these 4 plants. Typically, during a wired for polishing run at Watson Street, 17 lorries, each carrying 8 packs of glass, will be sent to Doncaster each day. One of these will be a special assignment, carrying a selection of glass from the previous 24 hours production. This allows Doncaster to process these special 8 packs and quickly ascertain how the Watson Street quality is affecting the Doncaster operation. Offloading is carried out in the rough glass stockroom by a sophisticated glass handling truck called a freight lifter. The packs are transferred either onto boussoir stillages for direct machine processing or into the stockroom. glass is then lifted from ground floor level to the grinding and polishing machine at first floor level by a large 27.5-ton overhead crane, which takes the Boussois stillages to the start of the grinding and polishing operation. Here, two automatic offloading machines place the plates onto a conveyor system which feeds them into the grinding operation. The grinding and polishing machine consists of 63 cast iron tables, and at any one time 49 tables are linked together to make a continuous grinding line. These are formed into a continuous line with some sophisticated heavy engineering equipment. This involves large raising and lowering wheels which bring the tables up to the line. Each table weighs over 8 tons, and the continuous line is powered by a 200 horsepower motor which drives the tables along a parallel pair of oil-lubricated slides. The setting of these slides is most important to the grinding operation, their corresponding levels being set to within thousands of an inch in order to minimize breakages and grinder cuts on the glass. At the end of the line, the tables are separated and lowered by a reverse process to that at the start, and then returned back to the start by way of driven track wheels which run under the main line. Before the glass is laid on the tables, a full-width cotton cloth is laid to support and cushion the glass. 4 cloths are in use at any one time, and a cloth lasts for about 1 month. They have to be presented on the tables in a very clean condition, since glass breakages can result should any dirt be present. So the cloth laying equipment incorporates brush and scraper equipment to ensure cloths and tabletops are clean. Once the cloth has been bedded on top of the tables, the glass is laid on the cloth by an automatic laying machine. Here, wax pegs are being injected at either end of the plate gaps. This protects against edge chipping by restricting any plate movement that occurs in the grinding and polishing operation. Grinding is achieved by feeding a sand and water slurry between rotating cast iron heads and the glass. This starts with a coarse grade of sand at the early heads, then finer and finer grades, to finish with a grade that produces a fine ground surface necessary to pass on to the polishing section. The sand grader plant is the heart of the grinding and polishing operation because any variations in consistency of grading quickly reflect in the quality of the finished product. So, checks on sand input, grader densities and grader granulometry sequences are regularly made and appropriate adjustments made to maintain the quality of the ground smooth finish. About 1/2 millimeter of glass is removed during one pass down the grinding section. Each grinder is powered by a 200 horsepower motor and has its own operating panel controlling both electric and hydraulic power. The grinder runners weigh 10 tons, cost £4,000 each, and the process wears out about 150 of these each year. It's in the grinding operation that the consistency of glass quality begins to show. Any variations in shape, stress or flatness will quickly show in breakage under the pressure generated by the grinding work on the glass. These effects on the glass can be seen in the trimming bay, the section between the grinders and polishers. Here the operator examines the glass, looking for breakages and surface grinding defects. He then makes sure that all the plates in this position on the line are pegged up properly to prevent any plate movement in the polishing section. He can also be called on to use plaster infills where parts are missing from plates, which will then prevent damage to polisher blocks. If polishing heads are kept down on unplastered broken plates, then a quality defect known as block rake can occur due to glass fragments becoming embedded in the polishing blocks and then scratching the glass plates on their traverse to the polishing section. Now on to the polishing section. Each polisher head has 2 spindles, one carrying 4 pads and the other carrying 6. The pads are 1-inch thick polyurethane and need changing about once a month. The 6 and 4 pad spindles are alternated down the line to form a pattern that gives a uniform polish across the full width of the plate. Rouge is fed onto the glass upstream of each polisher. There are 20 heads, and the last 3 are fed water only to aid the glass cleaning process. The rouge mixture is prepared in a mixing plant at the side of the polishing line and is then fed onto the polishers through a ring main system. The tanks supplying this are located outside the mixing plant so the operators can maintain a careful check on their operation. The rouge mixing plant also incorporates thickening equipment to thicken rouge that has been through the polishers and has been recovered after passing through drains and cyclone equipment which removes coarser solids. This recovered rouge is mixed with fresh rouge to form the basic ingredient for the mixture that is fed back to the polishers. A vital part of Doncaster's operation is the disposal of its waste products, which consist mainly of finer grades of sand, cast iron and rouge mixed with water, and this slurry is known as burgie. The burgie is pumped from the plant and chemically treated before it arrives at the settling beds where the solids settle out and the water is fed back to the river. The chemical treatment plant ensures that the water returning to the river conforms to the criteria set by the Yorkshire Water Authority. After polishing, the glass is examined to ensure that the standards of polished finish are being maintained and that the plates are not incurring any surface defects. The glass is then transferred by the stripping machine onto conveyors and is routed one of 2 ways, either into the warehouse or onto loaders for returning back to the start of the line. Because of the nature of the Doncaster grinding line, the final product is produced from a two-pass operation, so that after the first pass, the glass has to be returned to the start of the process for second side processing. A water spray in conjunction with a transverse brush system cleans the rouge and debris from the cloths, which are then rolled up and returned back to the start of the line. The glass is now washed and dried with an air knife and passed onto the warehouse examination booth. Here, each plate is individually examined and classified on its suitability for export, home or cut-down quality. All full-size plates are offloaded directly onto A-frames in loose pack form or onto bottom-end capboards or into gusset cases. Plates that are unsuitable for full size are directed by the examiner down the cutting leg of the warehouse. Here, another examiner checks to ascertain the optimum glass size that can be cut from the plate and programs an automatic cutting machine to cut these sizes from the plate. The cuts in the plate are then broken out manually. A small crane is used to move plates that can't be handled manually. This cutting and handling operation is in many ways a self-contained section of the warehouse. When the grinding and polishing machine is only generating first side glass and not transferring glass into the warehouse, stock glass for cutting can be fed into this cutting section. And by this mechanism, a continuous cutting operation can be maintained. If a lot of defective glass is coming down the cutting leg, the loader can also stack these plates for feeding in at some later time. This also ensures there are no disruptions to the production line, so that line slowdowns or stops are avoided. The operation of the whole plant, including the warehouse, is totally geared to minimizing the need to slow down the line or to stop the operation. Stops and slowdowns increase quality defects, particularly breakages. Glass packages in the warehouse for export orders essentially consist of end caps, gusset cases and open boarded cases for small off-cut sizes. Some loose export loads are dispatched on a special stillage called a mini jumbo. For the home market, the glass is all dispatched on tubular stillages in loose form. Typically, 40,000 to 45,000 square meters of glass leave Doncaster every week. 70% of this is for export, the main markets for polished wired being Holland, Germany and the USA. Particular attention has to be paid to all glass loads to ensure that glass arrives at the customer in good condition. A good cover of lucite interleavant powder is applied to prevent scratching and rubbing during transit, and the glass is carefully packed to specified standards and targets. Any deviation from these targets can cause scars or breakage problems during transit. The role of Order Execution Department, in conjunction with warehouse supervision, ensures that all equipment for loading is available, that the order progress is compatible with production and customer needs, and that the glass leaves the works to arrive at the customer's premises at the stated time. All these various aspects of order progress, packing, loading and dispatch are geared to ensuring customer satisfaction with the finished product. The team at Doncaster believe that the geography of the European market is such that the works can provide a first-class service to these customers in a much better way than its competitors, and hence provide Doncaster Works with a much sharper competitive edge.
The extra lessons that I was supposed to go to. My education therefore gave me the ability to either do one of two things, either to become a racing correspondent or a glass merchant. At the age of 21, in fact, I was appointed advisory director to the chairman of the company. At that stage, my father said to me, when I want your advice, I'll ask for it. So what I thought I would do is just quickly discuss the glass business and then get down to the real business of the day, which